Okay, we're back with the first example involving absolute extrema. So we're given a function, f of x, which is equal to simple polynomial, x squared minus 2x plus 3. Okay, and our goal is to find the absolute minimum value of f on the closed interval from 0 to 5. I know the glare is kind of hard for that line right there, but that says on the closed interval from 0 to 5. And what is the value of x in which this minimum occurs? So you got to be careful here. There's two parts. First of all, what's the x value where it occurs? And second of all, what is the absolute minimum value? When you see these types of questions, you want to make sure that you answer the question. Sometimes they ask, when does it occur? But more often than not, they ask, what is the value? So more often than not, they're looking for the y value. However, sometimes they may be looking for the x value or the independent variable. Okay, so we're going to do the candidates test in order to get this done. What does the candidates test ask us to do? Here are our steps. The first step, we're going to find the derivative of our function. Okay, when we find the derivative of our function, that allows us to get the critical points. Remember, critical points occur when the derivative is equal to 0 or does not exist. Okay, so we got to find those critical values. Once we get those critical values, those values plus our endpoints are our candidates, which is why this is known as the candidates test. It's actually, this is a local term based off of a longtime AP Calculus teacher from Hingham. He told a lot of people about it. He called it the candidates test. That's what I call it. It's not necessarily called the candidates test in textbooks, but it's known around here as the candidates test. So we're going to take all these candidates, and here's the key thing. We're going to plug them into the original function. Okay, we're going to plug them into the original function. Not the first derivative, not the second derivative, the original function. And we're going to get some results. The largest result, that's our absolute max. The smallest result, that's our absolute min. So here we're interested in the absolute minimum value, so we're going to plug our candidates into the original function and see which one produces the smallest number. Okay? But before we do that, we have to get all of our candidates. And we have to do that by getting our derivative and setting it equal to 0. So let's do that. We have f of x is equal to x squared minus 2x plus 3. That's a nice, easy derivative. We know that f prime of x is going to be 2x minus 2. Okay, that's the first derivative. That allows us to get our critical points. We set that equal to 0. I think you would all agree with me that this derivative is equal to 0 when x is 1. Okay, so that's one of our candidates. X is 1. The other candidates are our endpoints, 0 and 5. Now, just quick sidebar here. We found our critical number to be x equals negative 7. Okay, well, we're only interested in the interval from 0 to 5. So we would ignore a critical point candidate which is not in the interval in which we're interested. Now, 1 happens to fall in the interval from 0 to 5, so we will include it as one of our candidates. But it is possible for you to get candidates, one or more of them, in which you're going to just scratch them immediately because they're not within the interval in which we're interested. Okay, so we got our derivative, we found our critical points, now we're going to plug our critical points and our endpoints into the original function. Okay, so here we go. We need f of 0, because that's our left bound, f of 1, because that's our critical number, and then f of 5. And by no means do you have to do them in ascending order. Usually I will do that. Quite often you see that done on solution keys, but you can put them in any order that you want to. Okay, so let's plug 0 into the original function. Now be careful, don't plug it into the derivative. Make sure you plug it into the original function. So if you plug in 0 for x, we have 0 minus 0 plus 3. Okay, 0 is a good friend of ours. We get our answers really quickly. F of 0 is 3. Now we go to 1. If we plug in 1, we have 1 minus 2 plus 3. 1 minus 2 is negative 1, plus 3 is 2, so f of 1 is equal to 2. And now we go to 5. 5 squared is 25. 2 times 5 is 10. 25 minus 10 is 15. Plus 3 is 18. All right, so here are our three candidates, 3, 2, and 18. We are interested in the absolute minimum value, and the absolute minimum value occurs with the smallest result. The smallest result is 2. Okay, so to answer the question, what is the absolute minimum value of f on the closed interval from 0 to 5? We would say 2. Okay, that is the absolute min. 2 is the absolute min. Okay, and again, more often than not, that will be the question that is asked of you. But I did add a second question here just to make sure you can distinguish between the two. The second part of the question is, for what value of x does this minimum occur? Okay, 2 is the absolute minimum value, but it occurs when x is equal to 1. All right, it occurs at x equals 1. So that's like part B of our answer. But the key thing is that we're able to find the absolute min. Okay, so this is one question, just a basic function. This will be what your homework assignment starts off with. Going to do another couple of word problems just to give you a little more experience with this topic.